Hello friends, this is my new channel Mechanical Insights. Here you will get all the videos related to mechanical engineering. Today we'll learn stress strain complete concept in 5 minutes. Materials behave differently. You see different materials behave differently under different conditions. For example, rubber has long chain polymers and it will stretch when we apply force. The chalk is brittle in nature and it breaks very easily. Steel has crystalline structure and it will bend has way more strength than rubbers and chokes. So why these materials behave differently? For that we have to learn this concept. So first we talk about stress. Stress is defined as the internal resistance force per unit area. As you see in the screen here, this is a bar which is subjected to tensile force. When there will be force is acting in the outward direction as shown in green color, there will be resistance in the inner part of the body if it takes action axis along this line. So this is our resistance part, and same force is applied on the opposite side, then there will be reflection on this side. So this we call as internal resistance. The value of the internal resistance will be proportional to the force applied. So the value of the stress, it is denoted by sigma, is F by A, and the unit of the sigma is Pascal, or it may be in megapascal. You know the shaft diameter is measured in mm. So when you convert 1 meter square into 1 square, so you will get 10 to power 6 ratio. So this we call as mega. So this value is megapascal. If you take an example, there is a force of 1000 Newton act on 10 meter square area, then the stress will be equal to 1000 divided by 10. So this value will be 100 megapascal. As you learned in the previous slide about the stress, now here you will learn about type of stresses. So as you know, there will be three type of stresses acting on your body. First is tensile force. Tensile force is developed due to tensile means pulling. The arrow is in right direction outward, shows the tensile force. Next is compressive. Compressive means pushing, and the arrow direction will be opposite to tensile force. And in shear, there will be sliding force acting on the body. As you seen in the figure, there are two sliding objects and they are glued to each other. When we apply force in the outward direction, there will be shear stress will be developed. After getting the knowledge of stress, now you can define the value of what is strain. Strain is defined as the ratio of change in dimension to the original dimension, and it is also known as deformation per unit length. Here you can see that there is a bar of length L. When a force is applied P on the rod, the value of the L will be changed to L plus delta. So there is a change of delta. So when we divide this delta divided by original length, so this we call as strain. Strain is a dimensionless quantity. After getting the knowledge of stress and strain, now we discuss what is stress strain curve. As you see that stress strain curve is the graph plotted between stress and strain. It is defined in the experimental form. When a universal tensile test was conducted, then this type of stress strain curve will be developed for the mild steel. Here different parts are given: yield strength, ultimate strength, and fracture. The part we will discuss what are the different parts of this curve. So first is proportional limit. As you see in the graph, there is a straight line up to yield strength. This will call as proportional limit. From that we can calculate the value of the elastic modulus. And after the proportional limit, there is a area up to which the material will be in elastic state. So this we call as elastic region. And after the elastic region, there is a point at which yielding will start, is known as yield point. Then when we applied the force, there is a ultimate point up to which a material can sustain, is known as ultimate strength. And at last, when the force is so that the material has not able to restrain, the breaking point will appear. One important application of the stress is Hooke's law. Hooke's law states that the stress is directly proportional to strain within elastic limits. When we take the proportionality constant, it will come down to be Young modulus. Example of a bar of length 2 meter with deflection 1 mm, force is 100 Newton, and area is 1 square. So first we find the value of the stress. Stress is defined as force per unit area. Force is 100 Newton and area is 1 square. So the value of the 100 megapascal. Next we find the value of the strain, which is deflection per unit length. Deflection is 1 and the length is 2000 mm. Then the value of the is 500 micro. And then last is elastic modulus, which is defined as stress on strain. Stress is 100 megapascal and the strain is 500 micro. So the value of will come down to be 200 gigapascal. This is all about the summary of this video. Here the value of the stress we have discussed, the value of the strain, how we calculate it, and what is Hooke's law. If you are interested, I can make a detailed video on the Young modulus or stress strain curve. Thank you for joining my live. Please like and subscribe for further updates.